For homework, I asked you to sketch two simultaneous linear equations. The reason for that is we want to practice that skill today, except we're going to sketch simultaneous linear inequations. Okay, so there's a bit of a difference between the two. Okay, first of all, we need to actually sketch these two inequalities. Let's work out some points to help us sketch them. So the first thing is these will both intersect each other, okay, and I can work out the intersection point of the two linear inequations by using the simultaneous equations template or using my calculator, the ClassPad calculator. So let's type in my two equations, 2x plus 3y, and what I'll do is I'm not actually going to use the less than and equal to symbol because the calculator won't give us an intersection point at that. I'm going to just say it's equal to 6. The next thing I'm going to do is do x take y equals 3 and x comma y. Okay, so that tells us that the first point that we're interested in is 3 comma 0. That is this point right here. And that is where the two graphs intersect. So I know that that point there is common to both of these graphs. Okay, now I need another point on both of them. I'll treat the first one, I'll get another point for the first one first. Okay, so the way I do that is I look around. I could use many different ways to get a second point. The way I'm going to use is to get the y-intercept. That's not in y equals mx plus c form, so I'm just going to convert it into that using the calculator. So it's action, advanced, and solve, and I've got 2x plus 3y equals 6, comma, y. Okay, so now that basically is telling me that the function is y equals negative 2x on 3 plus 2. The plus 2 is the part I'm interested in. That's the y-intercept. So this graph has a y-intercept at here. Okay, so let's write our coordinates in. This is the coordinate 3 comma 0, and this is the coordinate 0 comma 2. Now let's see if I'm going to attempt to draw a straight line from connecting those 2 points, which is a bit hard on my stylus, but let's give it a go. Not bad. Okay, now remember that this is an inequality. That means that, well, first of all, I really should have checked. This is a less than and equal to sign. So I have drawn this correctly. This is a solid line. Remember, it's dotted if it's greater than or less than. And this is also greater than and equal to, so it's also going to be a solid line. Okay, I'm interested in then finding out which is the region required. So to find out the region required, I want to know when this inequality is true. So I choose a test point from either side of the line. Remember, it's either going to be this side that's true or this side that's true. So the point I'm going to choose is this one here, the origin. Okay, so 0 comma 0. So let's write the inequality. That is 2x plus 3y less than or equal to 6. Let's sub in 0 and 0 for x and y. You can quickly see that what will happen is it'll be 0 is less than 6. Now I ask myself the question, is this true? Is 0 less than or equal to 6? And it is. So that means that this here is the region required, and remember the way we're going to do this is we're going to shade out the region we don't require. We don't require this part here, so I'm shading it out. Okay, I'm not quite finished yet because this is a pair of simultaneous linear inequations, so I need to get a second line. So x take away y greater than or equal to 3. I'm going to put that also into y equals mx plus c form and find the y-intercept of that. Action, advanced, and solve. X take y equals 3 comma y. It tells me that the y-intercept is going to be at negative 3. So I mark that in. That's here. Negative 3. Let's put our coordinate point in. So that is 0 comma negative 3. Okay, now remember that that point there was the common point on both graphs. Okay, so that's where both graphs intersect. So I'm going to draw a line, or attempt to draw a line between there and there. Okay, here we go. Okay, again, not too bad. Now, what we'll do is then we'll find the region required of this particular graph, because either it can be on this side or it can be on this side. Okay, so I'm going to choose a test point, and the test point is again going to be 0, 0. So I want to see whether it's this side that's the true one, or this side is the true one, that is the region required. So I write down my test point, and I write down my inequality: x take y greater than 3. Okay, so sub in 0 and 0. 0 take 0 is greater than or equal to 3. 0 is greater than or equal to 3. Now I ask myself, is this true? Is 0 greater than or equal to 3? And this is not true. Okay, so this here in actual fact is the region we don't require. Okay, so this side of the graph we don't require. So let's shade that out. Alright, now what we have left is this part here is the only part of the graph that's actually unshaded. Okay, so this part here is the only part of these two simultaneous linear inequations that are true. The rest of it, the inequalities don't hold up, or the inequalities don't hold up. They're not true. Only in this part are they true. So I make sure I do my legend. So I draw a box and I write the words region required. Okay, and that basically means, look, anything that's unshaded, as in this part here, is going to be required. Everything else is not required. Okay, it doesn't work for this particular, or these two inequations.